convection current is a current caused by the expansion of a liquid, solid, or gas as its temperature rises. Now, when we talk about wind, we talk about convection currents. And that happens because warm air rises and cool air sinks. So if you look at your lecture notes before you do the simple convection currents lab, this should all make a lot of sense to you. Warm air rises, cool air sinks, and so when a cold air mass and a warm air mass come together, they want to jockey for position, and the colder one is denser, and it wants to get underneath the warmer one. Okay? If you look at the top of your convection current lab, it says that expanded material being less dense rises, that's the warm material, while the colder, denser material sinks. That's critical to this lab in being able to answer the questions. Okay? Convection currents are also seen in sea breezes and land breezes, and you should see that in today's lecture as well. There is a link that I've put on your convection current from Wiki Answers, and that describes convection currents very well. I would like for you to copy and paste that link and go ahead and watch it before we do the lab. So let's get started with the lab. I've already filled the plastic container 2/3 full of room temperature water, and I've let the water sit so that it's not being wavy and flopping around in the box. What I'm going to do is place 2 blue ice cubes in one end. Oops, I just made the water move. I'm going to put 2 blue ice cubes in one end of the tub, and I'm going to put a couple of drops of red food coloring into the other end of the tub. So this is ice cubes with blue food coloring, so they're cold, and putting a couple of drops of red food coloring into the other side. So if you start looking from the side of what's going on there, this is your observations. This is what you need to be paying attention to. So we're just going to watch it for a few minutes, and you can see the blue food coloring is sinking. It's traveling along the bottom of the container. That looks really good. That's a really good reaction. Sometimes this doesn't work quite as well. And now that you can see it coming up underneath the red food coloring is not warm. The water is fairly warm. So the red food coloring is just kind of following the path of the warmer water, while that blue food coloring is pushing it up and over. So if we were to watch this for an extended period of time and we get a good reaction, which it doesn't look like it's going to keep moving very much. Actually, the red is starting to shrink back a bit. What should happen is this red food coloring should slide over. And so what you get is this convection current with the blue dropping down, traveling across, the red rising and moving this way. And that's the type of convection current that you get in an ocean breeze, a sea breeze, and a land breeze. So this is modeling that convection current. Now, when you answer the questions in your lab, it asks you what happens to the red food coloring. All you have to do, oh yeah, it is still creeping across, actually, the red. What happens to the red food coloring? Just tell me what it does, and then say what type of air mass it represents. Remember, we're not representing water, we're representing air masses. So what temperature air mass does it represent? Those are easy answers. Then question 2, what happens to the blue food coloring? What type of air mass does it represent? And you don't have to say why any of this happens in these first 2 questions, it's just observations. Then conclusions, why does the food coloring behave the way it does? You need to describe both the ice cubes and the temperature of the ice cubes and why the blue ice cubes and the blue water moves the way it does. and why the warm water with the red food coloring moves the way that it does. And the answers are right on the first page, so that should be pretty easy for you to do. Then what you're going to do is you're going to draw from a side view using the example of a grassy field located immediately next to a blacktop. Use both words and a sketch to describe a potential convection current, noting directions of flow of warm and cool air. So what you're going to have is basically the same picture that you have now, or the same kind of picture you would have with a sea breeze or an ocean breeze, but you're going to draw it from the side, and one side is going to be blacktop and one side is going to be grass. You're going to draw it from a side view and just do a very simple convection current, and with a few words just and arrows show me what your convection current is doing. And that's it.